Okay, welcome to Architecture Basics. So general idea is this is just to distill a few sort of things that I use when I'm looking at the code to try and help make the code a bit cleaner. Because I guess over time as you code, the coding becomes easier, just writing the code part, and the more difficulty comes in how you structure the code, how the different parts relate to each other, and often making a good structure will make the code simpler, easier to understand. Oh, one PC. So most of these are like small little snippets, little ideas to consider. The big thing to remember is that all of these balance with each other. There's no right answer, wrong answer. There are often two different concepts that are complete opposites to each other that have to be considered, and you've got to learn to balance them and choose the right one for the right situation. So a big message that I want to get out is to think before you start coding. So sometimes a simple change, it's fine to just crack on, but before you code in, you need to think about what's the existing design of the sort of the few classes talking to each other or the subsystems that I'm working with, and how does my change affect that? Does it work within the existing design, or am I going to have to make changes to the design to better suit this? So understanding the domain. Often I'll just like sketch out on a whiteboard or some paper the relationships between the classes, objects, or subsystems. So a really good understanding there of how the existing pieces work before we start making changes. And how do they communicate with each other? The communication is often the key between a good design and a sort of not so good design, is getting that communication between pieces correct. So here's some examples of different designs from work. So in the top left, you can see this is an application level design, looking at how different applications work with each other for quite a big feature we're implementing. Top right is the design of an application. So this is an old DocGen design where we're looking at how the different microservices and components interact with each other. And then bottom left is one from Mr. Hub, where we're actually looking down at sort of more of a class level or a component level about how each piece interacts. So that's probably more what we're talking about today. So thinking about the domain is really important. If you read domain-driven design, there's like a really important bit about domain language, trying to agree on what the words are that we call the different concepts. Also remember that we're trying to model the problem space. So words that exist within the domain or the business should often be seen a lot in the code. When we start creating our own concepts, it makes it a lot harder for the business to understand what's going on. And this always has to be done. We're trying to reduce the amount of new concepts we're creating will make things simpler. Also grouping things by the domain or vertically. So we see this going quite well in some of the Angular apps today, like where you've got it's grouped by feature, but historically some applications had more like horizontal designs where like a class library would be like, oh, here's all my services or something like that. Whereas what we wanted to try and do is group the other way by like, here's all of the things related to some specific feature or subset of features. So class and object APIs. So what I'm talking about when I say API is the interface to that class or object. So how does that class share data, or preferably share functions and open up communication with other classes or objects? So when we're designing these, we want to think about what does it represent within the domain? What's its job? We're trying to build like this singular thing. It's like you should be able to draw out a class diagram and say, oh, this thing's job is to do this. And they should all be very cohesive with each other and simple. Then the big thing in drawing out these is to achieve a task, what pieces are going to be working on that task? How do they communicate with each other? Because we want to try and keep those communications simple. And a big part of this is coupling and cohesion. So we want the classes to be loosely coupled. So they're not too related to each other. They don't tell each other too much about what they're doing internally. And we want them to be cohesive so that class or object does one single thing. So we're going to start a little talk about conditional logic and where it sort of fits into like how it relates to a design. So a lot of the time, the more conditional logic you see, the more the code is actually diverging from a design. So if we look here at in the top left, we can see basically to start a really simple version of a method, and it's basically going through and doing its task list. So this is a sort of really non-conditional. There's no multiple paths in this. As we fix bugs and find edge cases, what we generally do is go and add conditions into our functions, complicating the flow by quite a lot. And when you look at a function, it's got lots of conditions. Often it's a sign that you probably need to start changing your design to match up to account for all these edge conditions. So I'd say it's fine to have them for a bit, but what we'd normally do is build something that's got a reasonable design, not that much conditional logic. As we go in and make changes, more and more conditions, at some point we need to go, we need to refactor the design and update the code to match a design that encapsulates a lot more of these problems. So one of the simple little ones we do is just to use dictionaries to pull out different functions for different things. But in some ways this is still conditional. I guess a main thing would be it's a design at a bit higher level. Cool. This sort of leads into configuration. And one of the things that I've seen a few times that I'd sort of like to highlight is sort of things like type checking or looking at what's being passed into a function can often be a very simple thing we can start to eliminate that can make our code a lot more flexible, and it doesn't really have a massive cost. So if we look at the example on the left, and this could be in a type language, could be actually checking the type in an inheritance structure that comes in. Basically we're saying, if it's this thing that's been passed in, do this. And what will happen is those conditions will expand as we have different paths, and this thing can be spread over several functions. So all of our sort of configuration logic, which is saying how each of these pieces operate, is spread amongst our code. And what we can start to do on the right hand example is pull that into little configuration blocks. So the object itself actually says, I want to generate images in this case, rather than if it's one of these, generate the images. This is a really cheap way of us then going, actually, if I had a new one that wants to do this, I can set a flag. And it's just switching over to say, if the thing tells me to do this, rather than if the thing is one of these, do this. It makes it a lot more flexible. And then also these little configuration blocks over time can get pulled out into configuration management systems. So we could put it in a database or a store, and potentially users can configure new ones of these. So reusability is a really key problem that we face. I would generally sort of say on this is start off, if you know something's going to be used all over the place, fair enough, extract it. Otherwise, inline it, make sure everyone else on the team is aware. It's a lot easier on a smaller product that these things exist, but not necessarily always pulling them out. You can get to sort of strange cases where two methods call a shared method, but they actually kind of expect it to do slightly different things, and changes in that can break one or the other. We'll probably go more into that in a future talk. Also, one of the tools I use is thinking about what something represents within the current context. So if we look in the top left here, we've got a HTTP call, which is quite a sort of technical concept. It doesn't really represent something within our domain. What we can do over time, if these get complicated, is wrap that up in sort of a wrapper that says what I'm actually thinking it is. This isn't always the best way to go. In a trivial example like this, I would just leave the HTTP client in because it's not hard to explain, and adding extra layers adds different types of complexity. A good example that I see on this is in a lot of typed code, the variable name matching what the class is. So say I've got a SurveyHub API client, which is a noddy sort of example I've made, but that would represent a subsystem that communicates with another application. From within my function, I don't care that it's an API client. All I'm saying is I think of this as this subsystem. It's not necessarily that one class within the subsystem. And little things like this is what does this current function view that other thing as, and give you some sort of good ideas on how to simplify the code and make it a bit more readable. So code leakage, sort of an interesting one. This can happen between classes, but it's a lot more dangerous between subsystems. If I'm oversharing data or structure between two subsystems, what happens is bad decisions made in one of them will leak to the other ones. You can sort of find, I guess, these examples quite quick. If you refactor a property on something and find it's used in a couple of hundred places, probably means that that's leaking between subsystems, which can really make it hard to like break things down. If you keep those boundaries good between subsystems, you can afford for one of the subsystems to have sort of bad code in it or like less well written code. Whereas if those boundaries are terrible, what happens is like everything bad just passes through the whole system. What changes, there's no such thing as a small change really. They leak between them and affect each other. And one of the key things to this is on your boundaries, if they're well designed, the data passed between them will normally be quite simple. It's not always achievable, but if you can go for that, you're going to stop things spreading. So like a good extracted sort of method or something will have simple parameters. If you see something with lots and lots of parameters, it's generally probably not the best break point. Yeah, so sort of design smells. So yeah, lots of parameters on methods normally means is maybe the concepts weren't broken properly. So they've been extracted out because the function's getting too big, but not necessarily in a way that's really designed. Class names not in the domain. This one always happens. It's just one to keep thinking about, like try and have your classes represent something in the real world or the problem space. Another one, big one, is inheritance structures that aren't represented in the domain. We'll touch on this more later when we probably cover inheritance versus composition. But a big one there is the only time, in my opinion, you should be using inheritance is when it represents a real structure in the domain. If you're using inheritance for code sharing, a lot of the time it's going to hinder you as you go forward. There are a lot of other mechanisms for code sharing aside from inheritance that won't cause these problems. So yeah, refactor a lot. Now, one of the strong ones here is, I think a lot of the time we refactor just to clean the code. And it's not that, in my opinion, that's not really the power of refactoring. Refactoring is, we've decided that there's a lot of edge cases in the code and we want to update the design to include the edge cases, so remove that conditional logic. So that's the idea of refactoring. We're not changing the functionality, we're updating the design to match the problem space. And a lot of the time we might do this just before we're about to add a new feature. So you might refactor the design first so that it makes it easier to add that new feature set in. Yeah, the classic, keep it simple. So everything like this, when we touch on patterns in the future, they're all really great, useful tools. But a lot of the time, we have a load of microservices just consist of a single file because the problem that thing is solving is not that big, and adding in tons of structure about it actually creates different kinds of complexity that make it hard to work with. It's always a balancing act. Another one I don't think people do enough sometimes is going back to the drawing board. If your head's starting to hurt on a problem, or you keep adding additional edge cases all the time, like more and more conditions, the complexity of what you're working on is increasing, or especially when you fix one thing, another thing break. These are all kind of hints that maybe you need to like step away from the computer, pen and paper, whiteboard with some teammates, draw the actual design of the existing system and explain how your change is actually affecting the design or working within the design. And this will often make it a lot easier to code once you understand how you're relating to all these pieces. Yeah, that's it. Does anyone have any questions? Okay, I'm going to start recording now. Credits.